All right, this is practice exam 2, section 1, part B. So this is still in multiple choice. You get to use your calculator, and we're going to do 76 through 83 in this video. Okay, so our first one, 76, says the position function of a moving particle is s of t is equal to 5 plus 4t minus t squared. Between 0 and 10 seconds. What is the maximum speed of a particle between 0 and 10? Now, this one is a little tricky. You have to remember that speed is not velocity. Okay, speed is going to be a positive number. It doesn't worry about direction. Okay, so that automatically, so you had to remember your physics. That's kind of tough. Automatically, that throws out A. All right, so we get velocity by taking the derivative of position. So that's going to be 4 minus 2t. And what is going to be the largest magnitude between 0 and 10? Well, if you plug in 0, it's 4. If you plug in 1, it's 2. The biggest number is going to be 4 minus 2 times at 10 seconds. That's going to be negative 16. However, again, I said speed is a scalar quantity, so it's actually going to be, that's telling you it's going to the left, the negative 16, but it's actually positive 16, so it would be D. All right, 77. So 77, we've got our calculator. What you want to do, if you want to know how many points of inflection, is to graph. All right, graph. So you should give this a try. Graph y is equal to cosine x squared. And I'm going to go ahead and draw, what that graph looks like. But it looks something like that, okay, in between 0 and pi. So you have an inflection point where it changes from concave down to concave up. So that would be something like right here. It's just asking how many inflection points. And probably something about right there would be another one. And then again, somewhere about right there. So since you just want to know how many inflection points there are, you don't have to go through and set the second derivative equal to 0. You really just have to graph it and eyeball it and know, okay, what is an inflection point? It's where concavity changes, and where would those roughly be? It'd be something like that. So between 0 and pi, you would get 3 inflection points. So that is answer D. All right, so truly a calculator problem there. Okay, 78. I think I'm going to try to fit that on the board right here. So we've got x, f of x, four, 6, 8, 10. And f of x is 2, 2.4, 2.8, and 3.2. And we want to know the using a right endpoint rectangles, approximate the value of 4 to 10 of f of x dx. All right, so each of our bases is going to be 2. So the base for this rectangle is 2, for this rectangle is 2, for this rectangle is 2. And then the height is the right value. So the height for the first rectangle is going to be 2.4, for the second rectangle 2.8, for the third rectangle 3.2. So it's going to be our first base of 2, height of 2.4, plus a base of 2, height of 2.8, plus a base of 2, a height of 3.2. If it had been a left sum, you would have used the left value, 2, 2.4, 2.8. If it had been a midpoint, you would have taken the midpoint between each of these two. All right, so when you add all of those up, you get, let's see, you're going to get about 16.8. All right, so you can go ahead and give that a try in your calculator, but that is answer D. Okay, so that one, those first three are really not bad. Not bad at all. '79. So we have a differentiable equation f. We have f of -1 is equal to 2, and f prime of -1 is equal to 1/2. So what this is our original point. F of -1 is 2. So we have the point -1, 2. And at -1, the slope is equal to 1/2. That's what this is saying. Slope equals 1/2 at x equals -1. So we want to use the tangent line equation to find the approximate value of f of -1.1. So let's get the tangent line equation. It's y minus y1 is equal to the slope times x minus x1. So that's going to be y minus y1 is 2 is equal to the slope 1/2 times x minus -1. X minus -1 will be x plus 1. So y is equal to 2 plus 1/2 times x plus 1. What is y of -1.1? Well, you just plug in -1.1 for x. So that's going to be 2 plus 1/2 times -0.1. Okay, so that'd be -0.05. So that'd be 1.95, which is answer D. So that is the tangent line approximation. You get a tangent line equation, and then for points near -1, you can get a pretty good approximation, and -1.1 is near -1. All right, so we did do these kind of problems in chapter 3. All right, going pretty good. So that's number 79. Number 80. Area under the curve of y is equal to the natural log of x over x is 0.66 from 1 to b. B is greater than 1, then the value of b is approximately. Okay, we've just got to set this up. Area under the curve would be 1 to b, natural log of x over x, and it says that's equal to 0.66. So you've seen a couple of these before where we're having to solve for this number, not this number. All right, so first of all, we're going to need to integrate. This is a u substitution. Let's let u be the natural log of x. Du is 1 over x dx. Forgot the dx there. Okay, so we can rewrite this as 1 to b of u du. And that's going to be 1/2 u squared, which would be 1/2 natural log of x all squared, evaluated from 1 to b is equal to 0.66. Glad it's not 0.666. Okay, so this would be 1/2 times the natural log of b all squared minus 1/2 times the natural log of 1 all squared is equal to 0.66. 1/2 natural log of b all squared. What's the natural log of 1? Well, that's 0. Of course, you have your calculator. If you forget, you can just put it in. is equal to 0.66, and then just use the solve function on your calculator. Okay, you could even say, you can do it that way. You could say natural log of b all squared. Of course, you probably put an x in is equal to 0.66 times 2, so that's that'd be what, 1.32. But your calculator should be able to handle it just like that. And solving for b, right? B is 3.15. And that is C. All right, so we've seen quite a few of these. I think you should expect to get one where you have to solve for one of the values in the integrand. All right. I'll get out of the way for just a second if you need to pause. Base of a solid is enclosed by the circle x squared plus y squared is equal to 4. What is the approximate volume of the solid if the cross sections of the solid perpendicular to the x-axis are semicircles? Okay, this one's a little on the tough side, but it's doable. So first of all, you have to recognize that's a circle with radius 2. Okay, so let's draw that in. So if it's a circle at the origin, centered at the origin, radius 2, it'd go from -2 to 2. Now what it's saying is that the shapes, you're going to chop this up into shapes, and the shapes you're going to chop them up into are semicircles. Okay, so we know solving, we're going to need to solve for y for this equation. So solving for y, it's going to be the square root of 4 minus x squared. It's actually plus or minus that, but we're not going to need the minus part. You'll see that in a minute. Okay, so what is the area of a semicircle? Well, area of a circle is pi r squared. So area of a semicircle would be pi r squared over 2. So what we're going to be doing is adding up a bunch of semicircles from -2 to 2. Okay, and we know that our equation y, our radius, okay, so that's the radius, is square root of 4 minus x squared. So the area will be from -2 to 2. I'm going to go ahead and bring the pi over 2 out front. -2 to 2 of the square root of 4 minus x squared all squared dx. Probably be easier to put that in your calculator since the square would lift the radical as just 4 minus x squared. All right, so if you throw that into the old calculator, you should get 16 pi over 3. So give that a try. Email me, text me, whatever, if you didn't get that and you want a FaceTime. But that is answer B. Okay, so that is something you'll have to probably do. Semicircle is about the most difficult shape you'll end up getting. It's probably going to be a square or a rectangle. Okay, but semicircle, instead of pi r squared, the area is pi r squared over 2. It's half a circle. All right, let's look at number 82. And I think I can fit 82 up here. So it says the temperature of a cup of coffee is dropping at a rate of f of t is equal to 4 times the sine of t over 4 degrees between 0 and 5. The coffee is initially 95 degrees. what's the temperature to the nearest degree 5 minutes later? So you want to add up all the degrees of temperature lost. To do that, we integrate. We're not getting a rate, we're summing up everything. So the coffee started at 95. We're going to subtract out from 0 to 5 minutes of that function, 4 times the sine of t over 4 dt. So start at 95. This integral sums up all the loss of temperature over that period. All right, so if you put that in your calculator, it's going to be 95 minus about 10.95. So approximately 84 degrees, which is answer A. Okay, so if you know what you're doing, that's a real fast one to do. So as short as this problem is, it's a really important one to understand. Okay, this will be the last one for this video. Okay, 83. 83 is not a tough one at all. It says the graphs of f prime, g prime, p prime, and q prime are shown below. Which of the functions has a relative minimum from a to b? Well, a minimum occurs where the graph of the derivative